organize different events like scope of climate resilient crop breeding and genetic improvement in maize, new climate resilient hybrids of maize, climate smart soil management, soil and irrigation management, and as well as disease and pest management also. The role of technology in enhancing climate smart maize cultivation. This is the smart introduction of the program. And in this series today, we are going to organize a lecture. And today's speaker is Dr. Ramesh Kumar. And Dr. Ramesh Kumar is principal scientist in Indian Institute of Maize Research in discipline of plant breeding. He has an experience of more than 12 years in maize breeding, specifically on quality breeding and stress tolerance. He has developed so far 20 maize hybrids in different categories like UPM, normal corn, and baby corn and other specialty corns also. And 8 inbred lines has been registered in NBPGR for different traits. And these inbred lines are also being used in the breeding program in our institute also, as well as in different AICRP centers. And the developed hybrids are in the seed production chain, and some of the hybrids are at the farmer's field, and their performance is also very good. These and he has earlier than maize he worked on cotton crop. In the cotton he has developed 4 varieties of the cotton and 4 lines also registered for different traits. And he is also taking care of AICRP maize as a nodal officer of AICRP since last 5 years. And more than 80 research paper he has published in maize and in international and national research journals. And he has authored one book and more than 15 book chapters, and I think more than 25 popular articles he has published. He has also visited Germany, Thailand, and Nepal for different trainings and symposiums and conferences are also. And he has conducted a lot of trainings. This is countless. I could not find the exact number, so I think it is countless. So many trainings for the farmers with respect to maize technology, maize seed production, hybrid seed production for farmers. And he is also taking care of the ABI center in institute. So maize value added products, he is providing trainings in different batches for different categories of persons in different way for the different value added products. It is just a brief introduction of the today's speaker. So I request Dr. Ramesh Kumar to address us for the topic on breeding for heat stress tolerance in maize. Thank you, sir.
Dr. Dagla.
Yes, sir.
Hello.
Hello. Yes,
Allow
sir.
me to share. Allow me to share. अभी
Okay, sir.
शेयरिंग राइट्स नहीं दिए मुझे.
सर शेयर कर सकते हैं सर.
Okay,
कर
sir.
सकते हैं.
Yeah.
वो तो नीरव है अभी. ओके.
शेयरिंग का वो दे रखे सर आप.
यस 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 हो गया हो गया हो गया हो गया. Good morning, each and everyone. Dr. Shekhar, Dr. A.K. Singh, my colleagues Dagla, Roman, SL, and other colleagues from AICRP, Dr. Mahadev, Jahur, and I could able to see some names, Subhash, then Preeti from HAU, and other colleagues. Thank you, Dr. Dagla, for giving me a chance to interact with my own colleagues in AICRP, and I will speak on breeding for heat stress tolerance in maize. What we can do, what we are observing, and what we are doing. Colleagues, you know that when we see the maize mega environment of the South Asia, 60% area is heat or drought or heat plus drought stress prone areas. And out of this 20% total cultivation is 20% is irrigated. Out of this 20%, you know that 7% is cultivated in spring season, which is high input environment, but very heat stress prone. And 13% is winter cultivation, that is high input or high yielding environment, almost stress-free environment. And 80%, which is under rain-fed, particularly during rainy season, out of this 80%, 11% is having optimal moisture, so there is no major stress. And approximately 20% that is affected by drought, and because that area is having less than 500 mm rainfall, so drought or sometimes heat stress is also observed there. 16% area that is having more than 1500 mm rainfall annually, so in these areas excess moisture or waterlogging stress is there. And 30%, 34% area is such area where, due to erratic distribution of rainfall, we used to face the drought sometimes when there is no rain, drought-like situation, and temperature is high, then heat stress is also there. And when heavy rains are there, waterlogging. So all type of stress in same crop cycle we are facing. Friends, when we see the global mean temperature, you can see these are the 12 years which we have observed globally that are considered to be the most warmest year during the last century. This is the global average temperature. The NASA, the Japan Meteorological Department, then the United Kingdom Meteorological Department and other agencies, they have concluded that the temperature is increasing every year. And by 2025, there will be a change in temperature, more than 1 degree change in temperature. The temperature will be higher. When we talk about India, we observe that 0.6 degree temperature annually.
आपका slide move नहीं हो रहा है, sir.
Slide move नहीं हो रहा. हेलो
नहीं डॉक्टर साहब, स्लाइड वहीं पे है, पहला ही.
अरे मैं फिर से करता हूँ, स्टॉप शेयरिंग करके फिर आता हूँ.
फिर शेयर कर लीजिए.
ये तो भाई कुछ और प्रॉब्लम होगी. अब आया है?
आ रहे,
आ गई ना?
आ गया.
सर
मैं
इसको
चाहता
फुल
हूँ
स्क्रीन
सर,
करिए सर, एक बार फुल स्क्रीन.
फुल स्क्रीन कर दूंगा.
मूव तो हो रहा है.
अब दिखाई दे रहा ना?
हाँ.
When we talk about the global mean temperature are rising fast with time, and you can see in this case
रमेश स्लाइड मोड पे,
warmest year.
प्रेजेंटेशन मोड पे.
हाँ सर, क्या प्रॉब्लम आ गई?
प्रेजेंटेशन मोड पे.
प्रेजेंटेशन मोड पे है सर. ये तो
वो फुल स्क्रीन वाला जो करते
यार फुल स्क्रीन ही है. मैं फिर से कर देता हूँ भाई.
नहीं जरूरत नहीं, उसमें ये है ना.
आप देखो सर, अब ठीक है.
ठीक है, कर लीजिए.
These are the 12 years which have been identified as most warmest years. Then when we see the global average temperature change, different agencies, NASA, Japan Meteorological Department or UK Meteorological Department and other agencies, they have concluded that by 2025, the temperature in change will be more than 1 degree C. And when we talk about India, there will be 0.6 degrees C more temperature we have already observed in last 114 years. And due to increase in temperature, there is a decline in monsoon also. Since 1950, we have seen this, and a 2 degree C rise in global average temperature that will disturb the monsoon in coming days more advertently. And when we talk about the droughts, perhaps most of us belongs to the same era. And in 1987, there was a severe drought in North India. I have seen that our farmers in our area, they had to feed their animals by chopping the thorny bushes also. Perhaps Bharat Bhushan also have seen this situation. I was in school days at that time. I was in the 8th class, and we have seen this 2002, 3, and 9 drought also that affects more areas in the country. When we talk about the projection of warming in India, by 2030, it is expected that the temperature will be warmer by 1.5 degree, and it is expected by 2080, 4 degree C higher in the temperature we will observe. When heat waves, we will talk about the heat waves, 50% of the country that will get heat waves of more than 3 degree more temperature than the normal one, and 20% area with 2 degree and 15% area with 1.5 degree. So almost 85% of the country will face heat waves in coming days. Dear friends, then by 2000, I have already explained that expectedly there will be change in the temperature. The higher temperature will be by 4 degrees C. So again, by considering different models, it is concluded that the change in the temperature will be from 2 degree to 4 degree C. It will be warmer than the normal one. When we talk about the temperature, how it is affecting maize, above 30 degrees C temperature for one day by 1 degree, that will reduce the crop production, maize production by 1%. And by 2080, it is expected that 15% yield loss will be there in case of maize by this higher heat stress or more heat stress. When we talk about the economic impacts in India, India may lose more than 3% GDP annually by 2100 due to this high temperature, and poverty may also rise by 3.5% due to the climate change in coming years. Friends, when we talk about this heat stress, nowadays we all are
सर
discussing
स्लाइड
हाँ?
सर स्लाइड नंबर 3 पर ही है अभी।
हो क्या रहा है, मैं तो 3 बार तो कर चुका। भाई नेटवर्क इश्यूज हैं। रोमन, डॉक्टर रोमन,
हाँ सर,
आपके यहाँ स्लाइड नंबर 3 है, ज्यादा है, कौन सा है?
स्लाइड नंबर 3 है सर, अभी मूव नहीं हो रहा।
सर स्लाइड 3 है, ग्लोबल मीन टेम्परेचर।
यार ये तो क्या हो रहा है, मैं तो 3 बार कर चुका, मेरे यहाँ तो नेटवर्क इशू भी नहीं है।
सर आप है ना उसको अनशेयर करने के बाद एक बार आप शेयर कर लीजिए, उसी में न्यू शेयर करके होता है।
अरे डॉक्टर साहब, डॉक्टर रोमन को भेज दो ना अपना प्रेजेंटेशन। रोमन विल डू इट।
रोमन मैं आपके पास भेजूं?
हाँ, रोमन को भेज दो।
मैं आपको भेजता हूँ।
ये हमारे स्लाइड
क्या नाम क्या सर उनका? रेहाना हबीब खान। Okay, a new guest also joined this presentation. She is Rehana Habib Kant, Dean College of Agriculture from Skust, Jammu. So welcome ma'am in this this lecture. You are welcome ma'am.
Roman, I have already shared.
Thank you, sir. Thank you. Go ahead. Go ahead.
इस समय डाउनलोड कर
रोमन,
हाँ सर मैं डाउनलोड कर रहा हूँ
हाँ आप डाउनलोड करके शेयर कर दो। मेरे यहाँ तो वाईफाई वैसे चल रहा, क्या हो रहा है नेट में? डॉक्टर मधुकर राव जिसवाइन।
एक मिनट
कुछ प्रॉब्लम आ रही है उसमें, स्लाइड नहीं चल रही, वो कर रहे हैं उधर से
यहाँ से शेयर करके देखो एक बारी।
ना, वो कर रहे हैं वहां से, वो शेयर करेंगे।
स्लाइड देखिए सर
हाँ डॉक्टर साहब आगे चलो, फर्स्ट चल रही है, सेकंड थर्ड फोर्थ पे आ जाओ। नेक्स्ट
ये आ गया क्या? एक बार देखिए
हाँ हाँ आगे थर्ड तक तो हो गया था, फोर्थ।
Roman is कहाँ? Yes.
Yes. Friends, sorry, there was some problem. And when we talk about this, ये इसको स्लाइड इसमें नहीं आ सकता क्या रोमन? स्लाइड शो में हो सकता है क्या? चलो मैं कर दूंगा, ठीक है।
सर हमें
When
तो
we
ये
talk about
slide
India,
show में ही आ
Okay.
रहा है.
Okay.
It's perfect.
India has risen temperature by 0.6 degrees C in past 114 years, and that is affecting our rainfall pattern also. By increasing the 2 degrees C temperature, India's monsoon is getting disturbed. And when we talk about the droughts, I have already spoken. So perhaps some people were able to listen or not. In 1987, we have faced a very severe drought in North India, and even people had to feed the thorny bushes and to their animals. There was no rain at all during this rainy season, and 2003 and 9 droughts that covers half of the India. And when we talk about the projections of warming in India, the temperature is expected to rise by 1.5 degrees C by 2030, and it is expected to rise in the temperature by 4 degrees C by 2080, and that will increase the efficiency increase the intensity of the heat waves more than 50%. 50% of India will get heat waves of more than 3 degree C temperature than the normal one. 20% India will get heat waves of 2 degree C temperature, that is more 2 degree C temperature than the normal one, and 1.5 degrees in 15% area. So more approximately 85% area of the country will face heat waves in coming days. Roman, next. Next one.
नहीं ठीक है
हाँ कर दो. So friends, by applying different models, it is concluded that by 2000, the temperature will rise by 2 to 4 degrees C. That is expectation in coming years. Next one यार, मैं भूल जाता हूँ, मेरा दबाता हूँ बटन. Next one. रोमन आपके यहाँ भी इशू आ रहा है क्या? Friends, when we talk about the effect on maize crop, the rise in temperature by 1 degree C each day above 30 degrees C. that will reduce the maize production by 1%, and it is expected that by 2080 15% yield losses will be there in maize. Next one. When we talk about the economic impacts in India, more than 3% GDP loss will be there by 2000 by high temperature or this heat stress, and the poverty may also rise by 3.5% by 2040 due to climate change, particularly this heat change. Then heat stress, Dr. A.K. Singh is there when we are talking about intensive cereal cultivation. Then we have introduced the third maize crop as a spring crop. This is a niche area, high productive area, and this is a very high yielding environment, but this is very much stress, very much prone to stress. Then again during mid-season heat is there during monsoon season also. Sometimes temperature is increasing, there is no rain, drought-like situation, as well as heat conditions are also we are facing in that particular season also. Next one, sir. Roman, next. When we talk about this stress, what is stress? Stress, that is to prevent full potential, genetic expression of one or more of the traits, and that creates adverse conditions for expression of these traits. Next one. Next one, Roman. Abiotic stress is the biggest challenge in crop production throughout world. And when we talk about the geographical distribution of the crops, approximately 20% area is native cropping pattern, crops, and out of this 24% area, 10% is inaccessible due to the abiotic stresses. Abiotic stresses are, this is the very prone to abiotic stresses, and more than 70% yield loss or reduction in potential yield of the different crops is reported in stress prone areas. And heat stress is one of the most common or most disturbing abiotic stress, which is reducing this agricultural productivity. Next one. Losses in case of drought, vegetative stage losses are reported to be 15 to 20%, and the reproductive stage yield loss is 20 to 50%. Whereas in case of high temperature, the yield loss is more than 40% at grain filling stage only, because at the time of grain filling, when the temperature is high, pollen availability is a issue, and the tassel blasting as well as the leaf firing is there, and pollen, this embryo abortion is more observed. So heat stress is causing more damage than the drought stress. Next one. Next one. Yes. Then this different symptoms. We are confusing when we record data in case of drought and heat. For drought stress, the identified traits are leaf rolling, then delay in silking emergence, ASI is elongated, abortion in embryo, poor seed set, leaf senescence, then kernel number is reduced and weight is also reduced. For heat stress, two major traits, leaf firing as well as tassel blasting. The leaf firing starts from upper side, it will go downwards. And in case of drought stress, you have seen the leaf senescence. Leaf senescence always starts from the lower side. And the tassel blasting, when tassel is blast, the drying pollen is dried, the pollen availability is also an issue, and silk is unreceptive, and plants remains barren because seed set is very poor in case of heat stress. That will cause huge yield loss. Next one. Heat stress, how we defined, it's a threshold level for a period of time that is sufficient to cause irreversible damage to plant growth and development. Once heat stress is there, it will damage in such a way that the plant cannot recover. Next one. And when we talk about the threshold temperature, the upper threshold or lower threshold level, which is determined by different scientists in control conditions as well as in field conditions also, how they explained in next slide. Next slide. For a cone, 38 degrees C is considered as the threshold temperature. And in one slide, I have shown that above 30 degrees C, by increasing in 1 degree temperature per day, there will be loss in yield. But up to 38 degrees C, maize crop can tolerate the high temperature. Beyond that level, it is not tolerable. So 38 degrees C is considered as the threshold temperature for heat stress. So that's why we are planting our material for screening for heat stress uh, during this particular spring season after 15 or 20th March, so that we can expose the flowering stage, the reproductive stage to high temperature, and that temperature should be more than 38 degrees C. And most of the times it is around 40 or 42 degrees C at the time of flowering or grain filling stage. Next one. Friends, this stress, heat stress is affecting different stages, germination to emergence, particularly this 8-leaf stage or knee-high stage, then early reproductive stages, silking and pollen shed. High temperature, higher the temperature at boot stage, the tasseling stage and milk ripe stage, all these are the susceptible stage. The grain setting will be low. Ultimately, there will be reduction in yield. And when more high temperature is there, the internodal growth is also reduced. Next one. Precision phenotyping for any stress experiment is most required. For that, we need to characterize the field sites where we can conduct such experiments, and proper experimental design as well as the selection criteria or selection of the traits is required. The list which I have shown, these are the most appropriate traits which must record in a heat stress experiment, and all these things along with these precision tools also, they are having equal importance for collection of the correct data, and we can utilize that properly to analyze that heat stress experiment. Next one. For recording data, leaf firing, how it starts from upper to lower side, it will go, and best time to record this is 1 to 2 weeks after anthesis. And in case of tassel blasting, drying of the complete tassel is there. There will be no pollen availability. So best time to record this is 1 to 2 weeks after tassel emergence. When tassel is emerged within 1 or 2 weeks, we have to record this. And for tassel sterility, you can see sometimes the tassel is, there is no tassel blasting, but pollen availability is not. There is no extrusion of pollen. So that is known as tassel sterility, and best time to observe that is 1 week after tassel emergence. In this case also, once the tassel emerges, within 1 week we used to observe this, because the pollen availability, duration of the pollen availability is approximately 7 to 10 days only. Next one. Next one. This criteria also, this was the main trait, this years per plant. When we calculate this, how many plants are there in one plot and how many plants bears the scopes. So number of years per plot divided by total number of plants per plot. That way, by using this formula, we can calculate the barrenness. Next one. When we use this pollen viability test, in case of heat stress tolerant genotype, pollen tube growth is there when we use agar media, and there is no pollen tube development. In case of susceptible genotype, pollen tube development is not there. Earlier, we were using this staining based pollen viability test, which is often misleading. Therefore, the pollen germination test, pollen tube growth test is more appropriate for this pollen viability test. Next one. We are facing some problems for this breeding for heat tolerance. This temporal and spatial variation of the temperature regimes, you know that how much variation is there in temperature, and to create such environment in field conditions, it is very difficult. Particularly this year, you have observed that perhaps we observed only 1 or 2 days more heat was there in under field condition. So it is very difficult. Environment is unpredictable. So under field condition, it is very difficult. So we need to conduct this experiment very precisely, and we need control conditions for this experiment. Lack of coordination, sometimes there is some problems among staff also. Breeder is calling his colleague physiologist, he's on tour, or meteorological data friend is not available, how he will get the meteorological data. Some like these problems we are facing. So in at some places, in some cases, coordination is also problem. So when we coordinate with each other in very well manner, we can help each other to record the data in such a complex experiment. Then we all know that complex nature of the tolerance mechanism also. Quantification is very difficult. When we record the data on tessel blasting or leaf firing, quantification is difficult. How much tessel blasting is there? How many percent was there? So it depends, because we have to record it visually. It all depends upon the visual observation or visual ability of that particular technical person or scientist. Then less information is also available. That very less information. Very less people are working on this. Though CIMIT, our CIMIT colleagues as well as at IAMR also, we have generated some information on this heat stress tolerance or susceptibility, and we can use this. I will show in next slides the identified material, how we can use this. Next one. This is the breeding strategy, how we can use this to develop the heat stress germplasm. Next one. Next one, please. We have conducted heat stress experiment under our HTMA project at different locations in India. You can see this temperature. Roman, press one more. Roman, we deliberately used to plant this experiment during mid-March so that we can expose our material, particularly the reproductive or flowering stage, to high temperature at Ludhiana, Raichur as well as Hyderabad, Kanpur. You can see the temperature during the flowering days, April or end of the May. End of the May, the temperature in most of the location is around 40 degrees C or above 40 degrees C. So deliberately we used to plant our material to expose. Sometimes during particularly, you can see this year, this condition is not possible because of the different weather vagaries. Next one, please. We have screened our material at IIMR Ludhiana, and we have identified, you can see these first 3 lines. There is no tessel blasting as well as no leaf firing. So these lines are considered as tolerant to heat stress. And you can see this LM11. This is tessel blasting is there. In other lines also tessel blasting or leaf firing is there. So by using this information, we can develop our mapping population. We can do QTL mapping, or we can develop population, or we can develop lines by pedigree cross also, by different ways and means. And all breeders know how to do breeding, so we can use this information. Next one. Next one. Besides the information generated, back one slide back. Dr. Roman, yes. Besides the information which we have generated, our CIMIT colleagues have also generated the information, and this slide I have taken from from CIMIT Dr. Jedi, that they have identified some lines, elite lines, which are having very good yield. These are the inbred lines which we can use in our breeding program for heat stress tolerance. They have identified the worst material as well as the best material for heat stress. So we can use this material, we can request them, they can supply, and we can use this in our breeding program. Next one. Again, these are the elite lines which are heat tolerance, combined heat and drought donors. You can see, you can use this as combined heat and drought donors. These are the best lines. After giving both stresses, they have given very good yield under such conditions, and these are the identified donors for heat as well as the drought. Next one. Then future thrust, identification of sources which I have shown. These are the few sources which we identified. More sources we can identify, and we can use these sources for breeding program. Then development of suitable and effective selection index. Though we have listed some traits, we can include more traits. We can include root traits as well as other traits also. Then we can develop mapping population, we can develop pedigree population, we can develop synthetic population by using these information, and we can do QTL mapping. We can transfer this QTL for heat stress tolerance, and we can pyramid the genes identified for different traits in different inbred lines in one population. We can pyramid that also. We can do breeding in such a way so that we can develop the tolerant lines, and we can use molecular marker also. Next one. Thank you all for listening patiently, though there were some issues, some problems, technical issues. I'm sorry for that. And thank you, sir. Thank you, Dr. Dagla. Now, Dr. Roman, you can unshare.
Okay, thank you, sir. Thank you very much for giving a very nice presentation on breeding for heat stress tolerance in maize. So I would like to request participants, if you have any query, please discuss. Hello. Am I audible to all?
Yeah, audible.
Okay, sir. Okay, thank you, sir.
शेखर सर नमस्कार, आपकी आवाज आई।
नमस्कार रमेश जी, ये प्रॉब्लम है ना, मंदिर में था, बाहर आया हूँ।
हाँ जी सर। हाँ सर, मेरा भी मैं वाईफाई से कनेक्ट कर रखा है, फिर भी पता नहीं क्या इशू आ रहा है।
रमेश जी, ऐसे है, हीट स्ट्रेस टॉलरेंट में हम लोग स्प्रिंग में सोइंग कर रहे हैं, हीट कंडीशन में तो इश्यूज आ रहे हैं, कैसे स्टार्ट आउट कर लेंगे इसको? क्योंकि बारिश
हीट चैम्बर होते हैं सर, कुछ जगह पे अवेलेबल हैं हीट चैम्बर में हम ग्रो करके, एंड वी कैन डू इट अंडर कंट्रोल कंडीशन। जितना टेम्परेचर है उतना टेम्परेचर रख करके हम उस पे स्क्रीन कर सकते हैं।
places ना nowadays March and April getting
yes sir, that is the only solution sir, control condition is the only solution for best experiment।
क्योंकि हम इतना मेहनत करते हैं, उसमें इश्यूज आ जाते हैं, एक्सपेरिमेंट
तो 3-4 लाइनें जो मैंने आइडेंटिफाई की, ये भी मैंने कंट्रोल कंडीशन में पीएयू की हेल्प ले करके किया था एक्सपेरिमेंट, वहां आइडेंटिफाई कर पाया। तो ये तो है सर इशू, इट इज वेरी डिफिकल्ट। इस साल मैंने सर एक एक्सपेरिमेंट 4 लोकेशन पे लगाया था हीट स्ट्रेस का, एट ऑल 4 लोकेशन वेदर इज नॉट गुड। मेरा कंप्लीट
मार्च अप्रैल, दिस इज अनयूजुअल ईयर ना, मार्च अप्रैल में
बिल्कुल
हीट स्ट्रेस
चारों लोकेशन पे ही खराब चल रहा है। लुधियाना, करनाल, हैदराबाद, 3 पे तो लगातार बारिश हो रही है।
तो मोस्टली एसटीएमए में होता है ना वर्क?
हाँ सर, एचटीएमए नहीं, मैंने एचटीएमए से अलग एक इसके इनबेड लाइन का ट्रायल बनाया हुआ था। एक मैपिंग पॉपुलेशन थी, उसकी आइडेंटिफाइड लाइंस थी, उसमें से कुछ 30-40 लाइन का सेट था। वो मेरा पूरा एक्सपेरिमेंट फेल हो गया। मैं सोचा मैं कुछ लाइन रजिस्टर कर दें, कोई मिल गया तो ठीक ठाक हो गया, लेकिन कुछ हुआ ही नहीं। नेक्स्ट ईयर के लिए चला गया, 1 साल डिले हो गया। 4 लोकेशन का डेटा चाहिए उसमें प्रॉपर। ठीक है सर।
Anybody else want to ask?
हमारा रमेश जी, हमारा रेनफेड ट्रायल का ट्रायल्स है ना, रेनफेड एएसआरपी ट्रायल्स।
जी सर।
इसमें स्प्रिंग से कल कुछ करलेशन है?
रेनफेड का सर स्प्रिंग में नहीं लगाते हैं। स्प्रिंग में तो रेनफेड का करते ही नहीं। स्प्रिंग की तो हमारी लोकेशन ही 3-4 लोकेशन है, अभी हमने स्प्रिंग का ज्यादा फैलाया नहीं है।
पंतनगर, लुधियाना, दिल्ली,
पंतनगर, लुधियाना, दिल्ली और करनाल, ये 4 ही हैं सर। यदि हम इसको और एक्सपेंड करेंगे ना, फिर बजट के इशू आएंगे, पैसा पहले कम मिलता है, हमें वो भी देखना पड़ता है।
बजट का इशू तो है।
हाँ, बजट का इशू नहीं तो हम रायचूर ले सकते हैं, हैदराबाद भी स्प्रिंग का ठीक है, चित्तौड़गढ़ भी ठीक है, 4-5 लोकेशन और हैं जिनको इंक्लूड कर सकते हैं। लेकिन उसका फायदा नहीं सर, पैसा कहाँ से आएगा? और फिर मार्केट नहीं है, मार्केट है सॉरी इसी एरिया में है, प्राइवेट वाले वहां आएंगे नहीं।
रमेश सर,
हाँ हाँ
sir, I want to ask one thing, that can we think of the heat induced male sterility for hybrid seed production?
भाई बहुत डिफिकल्ट काम है। पहली बात तो हीट स्ट्रेस एनवायरनमेंट, जो प्रॉपर एनवायरनमेंट आपको नहीं मिल रहा है, और आपको मेल स्टेरिलिटी बेस्ड मेल स्टेरिलिटी कर दोगे तो फिर पोलन कहाँ से आएगा? पोलन इज एन इशू, सबसे मेन इशू इसमें पोलन अवेलेबिलिटी है, और मेल स्टेरिलिटी आप फीमेल में करोगे, मेल का पोलन इशू तो हमारा दूसरा ना। पोलन अवेलेबिलिटी इशू होता है, तो उसमें मैंने आपको मेल स्टेरिलिटी में दिखाया ये एक ट्रेट, कैसे पोलन पोलन उसमें एक्सक्लूजन होता ही नहीं।
आपका जितना भी हीट टॉलरेंट इनबिल्ट लाइंस आइडेंटिफाई हुआ है, जो मैपिंग में लिया है रमेश जी, उसमें अर्ली में GT में है, मीडियम में, लेट में है इनबिल्ट लाइन।
सर ये मीडियम का मटेरियल है।
हाँ?
मीडियम का सर,
मीडियम का है।
हाँ अर्ली तो इसमें सर हम रखते नहीं।
अच्छा,
अर्ली नहीं रखते सर, अर्ली तो 100% एस्केप कर जाता है, इसलिए अर्ली नहीं रखा है इसमें।
ओके।
मेरा आप सभी पार्टिसिपेंट से रिक्वेस्ट है, प्लीज आप एक बार कैमरा सभी लोग ऑन कर लें हम लोग, तो जिससे क्या है कि हाँ स्नैप्स लिए जा सके एक दो।
जहूर जी कैमरा 2G में है क्या अभी?
नहीं, जहूर तो बीच बीच में ऑन कर लेता है। शेखर सर के यहाँ बहुत ज्यादा लाइट है, बाहर हैं।
अरे हमारा तो ऐसे होता है।
कोई नहीं सर, जो सिचुएशन है क्या करें, करना ही पड़ेगा।
सर अभी मुझे लग रहा है अभी कोई क्वेरी नहीं है, तो हम लोग आगे बढ़े सर।
हाँ आप अपना फोटो तो अपना तो ऑन करो कैमरा।
मेरा कैमरा सर इधर से ऑन है, लेकिन कुछ प्रॉब्लम आ रहा है, इसमें हो नहीं पा रहा है। मैं
चलो
कैमरा
आप ले लो
ऑन
फोटो।
हाँ हाँ
आप अपने यहाँ फोटो ले लो, आपका फोटो आना चाहिए।
हाँ सर वो हो जाएगा सर। So before vote of thanks, I would like to request Dr. J.C. Shekhar sir for his concluding remarks for this presentation. Sir, please.
These are the series pictures under national empire and mission. We are very thankful to technology. So to who has given the lot of information for breeding for heat stress tolerance in maize. We have a collaborative program. IMR is having a collaborative program under HDMA. So I think Godra, Kolhapur, and Varanasi are the main centers associated along with IMR. There is a need for us to have a heat stress tolerant major plasm and also hybrids in the coming years. We are especially increasing the temperatures and also especially heat stress to the maize crop. So there is a need to develop strong breeding program to develop hybrids. However, so far whatever we have achieved, it are giving some good results. So under Mars program, we have identified keep promising germplasm towards developing heat stress tolerance. Ramesh ji, thank you very much for giving a nice lecture. And also sharing the lot of information. Thanks to all IIMR and also ESAP partner who have joined in this important lecture series. Thank you very much.
Thank you.
Thank you.
Thank you. Thank you, sir. Thank you. As our tradition, culture, so it is time to do a vote of thanks for all. So first of all, I am grateful and thankful to our director, sir, Dr. H.S. Jat, sir, who has given us a very good opportunity to organize this campaign on climate resilient and smart agriculture. He has always been sportive and encourageous for all kinds of such initiatives in the institute, as well as through AICRP. I am thankful to Dr. Ramesh Kumar sir, who has given very informative presentation on breeding for heat stress tolerance in maize. And sir, it is very knowledgeous for all of us and very informative presentation you have given. So thank you, sir. Thank you very much. And I am thankful to Dr. J.C. Shekhar, sir, for his precious concluding remarks, which is will be the guiding path for us for researcher in this regarding climate resilient and smart agriculture and development of maize regarding the different abiotic stresses. And I am thankful to Dr. Rehana Habib Kant. She is Dean from College of Agriculture's Coast, Jammu. She has also joined this this event. So, ma'am, thank you very much for grace this event by your presence. And finally, I am thankful to Dr. Roman Sharma. Without his role, it is not possible to conduct this event for 1 week. And we have conducted all the events successfully in this campaign. This is the last event. This is the final event. So thank you all. Finally, I would like to thank all the participants who has given their precious time to us and listen from the heart to this presentation. Thank you all.
Thank you, Dr. Manesh, and thank you, Shekhar sir, Dr. A.K. Singh, and other AICRP colleagues, particularly Dr. Habib, Dean, President, College of Agriculture, Coast, Srinagar. Thank you, Dr. Zahur, for requesting Madam to join this program. Thank you, other colleagues, Dr. Madhukar. I could see name of few person. Thank you one and all.
Thank you, sir.
Bye-bye.